All right, so we're still in lesson 2.5. We're talking about inverses, but I cut off the other video because first of all, it was really, really long. Okay, but for this video, I just want to focus on how do you verify an inverse. All right, so I'm going to share my screen with you. All right, so here we're going to talk about verifying inverses. So the first thing is our learning target, and you have to be able to use composite functions, which is the f of g of x, g of f of x type stuff, to verify that two functions are indeed inverses of each other. So to do that, you're going to use composite functions, all right, but you're going to compare the solutions. So basically, if you have two functions, function one, function two, you're going to take one function and substitute it into the other one, f of g of x. Then take that other function and substitute it into the other. That's g of f of x, right? And when you do that, you're going to compare the solutions. If both solutions are equal to x, then the functions are inverses of each other. It has to be exactly x. If you were to do this and get positive x and negative x, then those would not be inverses because it's not x. If you got x plus 1 and x minus 1, not inverses. If you got x and then turn around and got 2x, well, again, not inverses. If you got 3x and 3x, not inverses. It has to be exactly x. All right, so let's look at a couple of examples. All right, so if we look at this first example, then remember what I said with the whole f of g of x, g of f of x. Basically, you're taking this function and you're substituting it into this function. And then you're taking the other function and you're substituting it into that function. So that's going to accomplish your f of g of x, g of f of x without really focusing on which piece you're doing. All right, so I'm going to do this first one. So instead of 4x, I have 4 times something. Well, this is what goes into that parentheses because I'm substituting it into the other function. So I'm going to put x over 4 in my parentheses. Well, if I multiply that, that's 4x over 4, which cancels out to give me x. Now I'm okay there, but remember, it has to be a comparison of both answers, both solutions. So I'm good on one, now I still have to check the other. Now, if I had done this and got negative x, then I really don't even have to do the other part because I've already not met that requirement, right? All right, so let's check the other one. All right, so this time it's this function going into the second function. So instead of having x over 4, I'm going to have something over 4. And the 4x is what goes into that function. Well, then again, the 4's cancel, leaving me with x. So because I got x for both of those by using composition, remember composition is when you take one and you substitute it into the other, all right? Then because of that, then I have verified, yes, they are inverses of each other, all right? So all of this other stuff, me substituting in, that's my work, and then this is my answer. Okay, so make sure that you don't forget to answer the question. All right, another example. All right, so for this one, I'm going to start off by substituting the second function into the first function. So I'm going to have 2 times something plus 1. Remember, x is just being replaced with parentheses because then this is going to go into my parentheses. So x minus 1 over 2 goes in the parentheses. All right, so now I need to solve that. Well, the opposite of dividing by 2 is multiplying by 2. So that actually cancels out, leaving me with x minus 1 plus 1, which minus 1 and positive 1 zero out, leaving me with just x. So we're okay on that side. All right, so now let's do the right side. All right, so now let me erase this part so you can kind of see what I'm doing. All right, so now I'm going to take this function and substitute it into this other function. So instead of having x minus 1, I'm going to have parentheses minus 1 over 2. And I'm going to take what I have over here and I'm going to substitute it in over here. So I'm going to have 2x plus 1. All right, Now here, I'm going to go ahead and start seeing, well, what cancels out? All right, so in the numerator, +1 and -1 zero out. That leaves me with 2x over 2, and then the 2's cancel, leaving me with x. So yes, they are inverses. All right, and just so you know, it's not always going to work out where they're inverses, okay? Sometimes it does, sometimes it doesn't. All right, another example. All right, so this time I'm going to take this function and I'm going to substitute it into this function. So instead of having x over 2, I'm going to have something over 2 minus 3. All right, and then the 2x plus 3 comes in. So be really, really careful here. Okay, this is where people are going to mess up. This is what somebody's going to do. Don't write this down on your paper, by the way. Somebody's going to go, boop, boop, and you cannot do that. The reason why is because these are completely separate terms. Okay, you cannot do that because this is a term and it's all being divided by 2. But is this part right here being divided by 2? No. So you cannot do that. All right, so you got to be careful. So really what you have is this right here would be divided by 2. So that would be x plus 3/2 minus 3. And I don't even have to finish that. I already know it's not x, right? So I already know it's not an inverse. All right, but I'm going to still do the other one just so that you can see, just in case, because what's going to happen is some of y'all are going to get to that point. You're going to be like, I think I messed up, right? So instead, let's try it the other way so that you can see that it still does not work out. All right, so this time, if I took this function and substituted into this function, then I would have 2 times something plus 3. And then the x over 2 minus 3 would fill in. All right, so here, if I distribute this 2, then I would have 2x over 2 minus 6, and then I still have a plus 3. This would give me the x, minus 6 plus 3 would give me a minus 3. Again, that's not x, so again, that just proves that those are not inverses. All right, so that's the math that you have to do in order to prove whether or not they're inverses. All right, one more example. All right, so this one's definitely uglier. All right, so again, I'm going to start with this one and I'm going to substitute into the f of x function. So I'm going to have 2 times something cubed minus 1. And then all of this is going to filter in. So cube root x plus 1 over 2. All right, now you got to think about order of operations. Please excuse my dear Aunt Sally. So we've got to deal with, exponents and things like that before we deal with multiplying. So what happens is when you cube a cube root, that part cancels out, leaving me with 2 times x plus 1 over 2, still minus 1. Now the 2's cancel because multiplying and dividing by 2 are inverse operations. So that leaves me with x plus 1 minus 1, which gives me x. All right, so we're good on that side. So now we just need to check the other one. All right, so we're going to now take this function and substitute it into the other. All right, so we're going to have cube root, and then x plus 1 is going to be parentheses plus 1 all over 2. So I'm basically taking this, rewriting it. It's just anywhere there's an x, I'm giving myself parentheses. So now this f of x function filters in. So 2x cubed minus 1. All right, so before I go dealing with this cube root, I need to take care of anything that I can that's on the inside, right? So because the plus 1 and the minus 1 are both a part of this fraction right here, then we can cancel that out. All right, so that part cancels, leaving me with the cube root of 2x cubed over 2. Well, now the 2's cancel out, leaving me with the cube root of x cubed. Well, now we're taking the cube root of a cube, right? Which cancels out, leaving me with x. So are those inverses? Yes, these are inverses. All right. Now, some real quick ways, and it doesn't always work like this, but these are some good ways, like if you were in a pinch and you wanted to look at something quickly, all right, to verify inverses. If I had something like this, if I had 2x cubed plus 4, and then I gave you a different function and I said, let's see, I don't know, the cube root of 1/2 x minus, or I'm sorry, plus 4, something like that. All right, well, automatically I would know that there was a problem. Why? Because this is a plus and this is a plus. And you need to think about inverse operations. Every time you do this work, you're going to be doing inverse stuff. So the opposite of multiplying by 2 is a divide by 2, okay? The opposite of a cube is a cube root, but the opposite of a plus 4 is not plus 4. So I would automatically know, without even doing any work, that those were not inverses, okay? But I don't want you to completely rely on that. It's a quick way to find out they're not inverses, but it doesn't always work because you'll notice here, divide by 2, multiply by 2, minus 3, plus 3. So you'll notice that those are kind of inverse operations, but look what happened. They were not inverses. So that doesn't guarantee that just because you see those inverse operations that they're going to be inverses of each other. However, if they didn't have those inverse operations, then that's a quick way for me to figure out that they're definitely not. Okay, so just kind of food for thought, and we'll talk more about that in our class. So that is how you verify inverses, and that is it for this. So let me stop sharing, and then you have some practice to do on your own.